So the last thing we want to check out is show that the following function has a left and right hand limit. Well, I got a slight typo on my slide here. It's not really a limit. It's going to be a derivative. So we want to show that this has a left hand and right hand derivative. So anytime we work with a derivative, we're going to use that whole limit process that we've seen a bunch of times, in previous lessons and at the beginning of this one. The limit as h approaches 0 of f of x plus h is what that should say. F of x plus h minus f of x all over h. How do we do that, you might ask? Well, we're going to look at these two guys individually. We're going to take a look at the top guy. We'll do him in pink. And we're going to look at this limit. Now I know there's some crazy stuff happening at 0. We just want to show that we can take a derivative at 0. And how do we do that? Well, we take the limit as h approaches 0 of f of x plus h. So in this case, we're going to look at f of x equaling x squared. So f of x plus h is going to be equal to x plus h squared. So here we're going to have x plus h squared minus f of x, which is going to be just x squared, all over h. So square out x plus h. And remember, when you square a binomial, you get a trinomial. So this is going to be x squared plus 2xh plus h squared minus x squared over h. We're looking at the limit as h runs to 0. And by the way, some stuff cancels out here, which is nice. This x and this x are gone. And so that's going to give me 2x h plus h squared over h. And I changed colors up on you, didn't I? For no good reason. And then if you'll also notice that there's an h here, and I can take away one of those h's. So they all factor out. And that gets me 2x plus h. Now, one of the things that we like about this is that as we look at our limit, and I need to just note that h is going to 0 here, then we can put a 0 in right here for this h. And so my limit is 2x. Okay, my limit is 2x. So when I do this, what have I got? What's the slope as we come in, as it were. And so when we look at the origin, our x-coordinate is 0. And so when that happens, you get 2 times 0, which is 0. So our slope with x squared is going to be 0. Hey, that's okay. We can do that. Well, what about the other side? Well, let's look at f of x equals 2x, and f of x plus h is equal 2 times x plus h. Okay? And so my limit then is going to be the limit as x goes to 0, as h goes to 0, of 2x plus 2h minus 2x. All that over h. And here we've got some x's that cancel out. And I have the limit as h approaches 0 of 2h over h. And the h's cancel out. And what I'm left with is a 2. That's my limit. The limit of a constant is the constant. So in this case, the slope is 2. Now, Since the two slopes are different, we can't actually take a derivative at 0. So this point that we're interested in has no derivative. But we could take a derivative from the left and the right, and that's okay. So this is an instance where, and there are a few of those, where you can take a derivative from left side and from right side, but can't actually take a derivative at a specific point.